Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to solve a differential equation using variation of parameters method. So let's get going. Problem. Solve y double dash minus 2y dash minus 3y equal to 64x e power minus x or d square minus 2d minus 3 into y equal to 64x e power minus x using variation of parameters method. So we are given a differential equation of order 2. Given differential equation y double dash minus 2y dash minus 3y equal to 64x e power minus x. Consider as equation 1. We can write y double dash as d square y by dx square minus 2 into write y dash as dy by dx minus 3y equal to 64x e power minus x. We can write d square y by dx square as capital D square y, where d is a differential operator, right? Minus 2 into write dy by dx as capital dy minus 3y equal to 64x e power minus x. Now take y common from all the three terms of LHS. We'll get d square minus 2d minus 3 into y equal to 64x e power minus x. Consider as equation 2, which is in operator form. Equation 1 in operator form is our equation 2. Say f of d into y equal to some function of x, where f of d is d square minus 2d minus 3 and r of x is 64x e power minus x, right? Let's now write the homogeneous equation of equation 2. The homogeneous equation of 2 is d square minus 2d minus 3 into y equal to 0. Consider as equation number 3. Now we'll find the solution to homogeneous equation using the auxiliary equation, and later using the solution of homogeneous equation we'll find the general solution of the given equations. Okay. Now coming to the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square minus 2d minus 3, right? Let's replace the differential operator d by m, so that we'll get f of m equal to m square minus 2m minus 3, and the auxiliary equation becomes m square minus 2m minus 3 equals to 0. Now we need to find roots to this equation. We can write this equation as m square. We can write minus 2m as minus 3m plus m minus 3 equal to 0. Now take m common from the first two terms and leave the next two terms as it is. Now take m minus 3 common from the two terms. We'll get m minus 3 into m plus 1 equal to 0. Now equate each factor to 0. We'll get m minus 3 equal to 0, m plus 1 equal to 0. Then from m minus 3 equal to 0 we'll get m equal to 3, and from m plus 1 equal to 0 we'll get m equal to minus 1. M equal to it's plus 3. 3 minus 1 are the roots, or m equal to minus 1, 3 are the real and distinct roots to our auxiliary equation, right? The roots are real and distinct. We know that when two roots, say m1 and m2, are real and distinct, then the solution to homogeneous equation looks like c3 e power 1 root into x plus c4 e power another root into x. We are taking c3, c4 instead of c1 and c2 because we want c1 and c2 to appear in the last general solution. Now coming to the solution to our homogeneous equation. the solution to the homogeneous equation. Equation 3 is y equal to c3 e power minus 1 into x plus c4 e power 3 into x. This gives us c3 e power minus x plus c4 e power 3x, right? Therefore, y equal to c3 e power minus x plus c4 e power 3x is a solution to our homogeneous equation. Let y equal to, we have solution to homogeneous equation c3 e power minus x plus c4 e power 3x, right? Now replace the constants or parameters with some functions of x, a and b. We'll have y equal to a e power minus x plus b e power 3x. Be the general solution to our problem. Where a and b are functions of x. Now, we can compare the solution to homogeneous equation with y equal to c3u plus c4v, or the general solution with y equal to au plus bv, so that you'll get u and b, where u is e power minus x and b is e power 3x. See? U is e power minus x and b is e power 3x. And here we are going to find a, b using some formulae. We'll get a from a dash equals to minus v into r of x by uv1 minus v1, and b dash is given, you'll get b from b dash equal to u into r of x by uv1 minus v1. If you notice, we are having uv1 minus v1 in both the formulae, so we'll begin with uv1 minus v1 and later we'll find a dash a, b dash b, and finally we'll substitute a, b in y equal to a e power minus x plus b e power minus 3x to find the general solution to our problem, right? Now coming to uv1 minus v1. v1 is nothing but v dash or derivative of v minus v into u1 is nothing but u dash or derivative of u. This gives us e power minus x into derivative of v, or e power 3x dash minus v into u dash, which gives us e power minus x into derivative of e power 3x with respect to x is 3 e power 3x minus e power 3x into derivative of e power minus x with respect to x is minus e power minus x, right? This gives us 3 e power minus x e power 3x minus into minus plus e power minus x e power 3x. See, e power minus x into e power 3x is repeating twice. We can write e power minus x into e power 3x as e power minus x plus 3x, which is equals to e power minus x plus 3x is 2x, right? Let's replace e power minus x into e power 3x with e power 2x. We'll get 3 e power 2x plus e power 2x, which is 4 e power 2x. Therefore, uv1 minus v1 equal to 4 e power 2x. Now coming to a dash is given by minus v into r of x by uv1 minus v1 equal to minus v is e power 3x into r of x 64 x e power minus x by uv1 minus v1 4 e power 2x. This is equal to minus 64x e power 3x into e power minus x. Since we know that e power 3x into e power minus x is e power 2x by 4 e power 2x. 4 ones are 4 16s are. This is equals to minus 16x. E power 3x into e power minus x can be replaced with e power 2x by e power 2x. E power 2x gets cancelled and you'll get a dash equals to minus 16x. Therefore, a dash equal to minus 16x. Let's now find a using this a dash. We have a dash equal to minus 16x. A dash is nothing but derivative of a with respect to x equal to minus 16x. Let's now separate the variables by taking differential dx to RHS. We'll get dA equal to minus 16x dx. Here the variables are separable. We can perform integration. Integral dA equal to minus 16 integral x dx. This gives us a equal to minus 16 into integral x dx is x square by 2 plus some integral constants is c1. This gives us a equal to minus 8x square plus c1. Therefore, a equal to minus 8x square plus c1. Now coming to b dash. It's c1, right? Sorry. B dash is given by u into r of x by u v1 minus v1. This is equals to u e power minus x into r of x 64 x e power minus x by u v1 minus v1 is 4 e power 2x is equal to 64x e power minus x into e power minus x by 4 e power 2x. E power minus x into e power minus x can be written as e power minus x, which gives us e power minus 2x. Now let's replace e power minus x into e power minus x by e power minus 2x. We'll get 64 16x e power minus 2x by e power 2x. We can just replace, or we can just rewrite it as 16x e power minus 2x into reciprocal of e power 2x. Since we know that reciprocal of e power 2x is e power minus 2x, we'll get 16x e power minus 2x into e power minus 2x. E power minus 2x into e power minus 2x can be written as e power minus 2x, which gives us e power minus 4x, right? So this gives us 16x. Replace e power minus 2x into e power minus 2x by e power minus 4x. You'll get b dash equal to 16x e power minus 4x. Therefore, b dash equal to 16x e power minus 4x. Now coming to b. We have b dash equal to 16x e power minus 4x, right? B dash is nothing but derivative of b with respect to x. Now let's separate the variables by taking differential dx to RHS. This gives us db equal to 16x e power minus 4x into dx, where the variables are separable. Now we can perform integration. Integral dv equal to 16 x e power minus 4x dx. Let's now evaluate integral x e power minus 4x dx separately for our convenience. Here we are going to apply integration by parts formula. Integral u dv equal to uv minus integral v du. Here the integrand is of the form product of polynomial function and exponential function, right? We'll consider the polynomial function as u and the remaining part as dv. We have u equal to x and dv equal to e power minus 4x dx, right? Now differentiate u equal to x with respect to x. This gives us du by dx equal to derivative of x with respect to x is 1, right? This gives us du equal to dx Here we integrate on both sides to find v. This gives us v equal to e power minus 4x by minus 4. Right? Now let's apply the formula. Integral u dv equal to uv x into v minus e power minus 4x by 4 minus integral v minus integral minus 4x by 4. V is minus e power minus 4x by 4, right? Into du dx. This gives us minus x e power minus 4x by 4 minus into minus plus 1 by 4 integral e power minus 4x dx, which gives us minus x e power minus 4x by 4 1 by 4 into plus 1 by 4 into integral e power minus 4x dx is e power minus 4x by minus 4. Again this gives us minus x e power minus 4x by 4 plus into minus minus e power minus 4x by 4 4s are 16. Therefore integral x e power minus 4x dx is minus x e power minus 4x by 4 minus e power minus 4x by 16. Since integral x e power minus 4x dx is minus x e power minus 4x by 4 minus e power minus 4x by 16, then the above equation becomes integral dv equal to 16 into integral x e power minus 4x can be replaced by these two terms. We'll get minus x e power minus 4x by 4 minus e power minus 4x by 16 plus integral constant say c2. This gives us minus 16x e power minus 4x by 4 minus 16 e power minus 4x by 16 plus c2, which is equals to minus 4x e power minus 4x minus e power minus 4x plus c2. Therefore b equal to minus 4x e power minus 4x minus e power minus 4x plus c2. We got a and b. So now we can find general solution using y equal to a e power minus x plus b e power 3x. Therefore, the general solution is given by y equal to a power minus x plus b e power 3x. Substitute a and b. We have a minus 8x square plus c1 and b is minus 4x e power minus 4x minus e power minus 4x plus c2. This gives us minus 8x square e power minus x plus c1 e power minus x plus into minus minus 4x e power minus 4x into e power 3x plus into minus minus e power minus 4x e power 3x plus c2 e power 3x, right? E power minus 4x into e power 3x is repeating twice. We can write e power minus 4x into e power 3x as e power minus 4x plus 3x, which gives us e power minus 4x plus 3x is minus x. Just replace this term by e power minus x, then this gives us minus 8x square e power minus x plus c1 e power minus x minus 4x e power minus x minus e power minus x plus c2 e power 3x, right? Now write the terms involving c1 and c2. Firstly, we will get c1 e power minus x plus c2 e power 3x. Now write the remaining terms. Minus 8x square e power minus x minus 4x e power minus x minus e power minus x. This gives us y equal to c1 e power minus x plus c2 e power 3x. Now take minus e power minus 3x from the last three terms. We'll get minus e power minus x times 8x square plus 4x plus 1. Or we can write this as y equal to c1 e power minus x plus c2 e power 3x minus of 8x square plus 4x plus 1 into e power minus x. This completes the problem. So we have seen a problem from variation of parameters method in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.